Okay, this is the review for the test number 1, second 6 weeks, spring 2015 for pre-calculus. These are 10 typical types of questions you will have on the test. The test does contain a combination of multiple choice and open-ended. This one here says, use a calculator to evaluate the expression cosecant of 4.5. Round answer to 3 decimal places. This could just as easily been a multiple choice. But anytime it tells you to round, that's a telltale sign that you're going to need to use the calculator. Now, cosecant of 4.5, this is not in degrees. In other words, there is no degree sign. Notice I'm erasing it. There's no degree sign, so it's a radian. So let's check to make sure we're in the right mode. And we are in radian mode there on my 4th line of my display there. So now that I'm in radian mode, all I got to do is just find the cosecant. Well, if you'll remember, the cosecant is nothing more than 1 divided by the sine of our angle. So if I just simply do 1 divided by the sine of 4.5, 1 divided by the sine of 4.5, there's my answer right there. It says to round to 3 decimal places. So that is negative 1.023. So that was pretty straightforward. And you will get a number of questions that are straightforward like that. Second question. It says, use the triangle below to identify the correct representation of the sine of theta. This is an abstract problem. This is not telling you to find any numbers. It's just telling you to simply find the ratio. Theta exists in this part of the triangle. Therefore, my sine of the angle theta is always the opposite side length divided by the hypotenuse. Remember SOHCAHTOA? SOHCAHTOA sound like Sal Khan from Khan Academy. SOHCAHTOA. Well, the sine is the opposite over the hypotenuse. And so therefore, in this particular problem, again, we're not using numbers or anything, it's just abstract letters. In this case, the sine of theta is b divided by c, because b is my opposite and c is my hypotenuse. So the answer is just simply this. And again, this could easily be a multiple choice question, or it could be an open-ended question. All right, this says to find the exact value of the cosine of 210 degrees. Now, if it says an exact value, that means then that that angle is an angle in which we know the coordinates of where the terminal ray crosses a circle. More specifically, it's going to be on our unit circle. Well, how do we know? Well, we've been doing a lot of stuff in radians, so let's just convert this to radians. I want to convert 200 degrees into radians. I'll multiply by pi over 180. Now, understanding that on the unit circle, all my angles are in terms of pi over 2, pi over 3, pi over 4, and pi over 6. I want to keep pi in my answer here. So really, here's what I'm doing. I'm doing 210 over 180 pi. And I'm just going to take my calculator, and I'm going to take 210 and divide that by 180, and I'm going to just fractionize it. So that's 7 over 6. So here's what I have then. 210 over 180 pi is the same thing as 7 pi over 6. So now, I mean, I could look at a unit circle, but I won't have that available on my test. So if you'll remember, if we do the hand trick part, you put your thumb along the positive x-axis and your 3 fingers out, and then your pinky along the the thumb is along the positive y-axis, and the pinky is along the positive x-axis. Of course, my hand doesn't look proportional there. The pi over 6 finger was the ring finger, and if we somehow eliminated that finger right there, then we have 3 fingers on top and 1 on bottom, which means that we have the square root of 3 over 2, comma, 1/2. Those are the coordinates, the square root of 3 over 2, 1/2, in absolute value terms. What we don't know is, are they both positive or are they both negative? That part we don't know. So now what we need to do is figure out in what quadrant does 7 pi over 6 land, because that's going to determine whether we have positives or negatives. By the way, cosine, let's go ahead and start solving this. Cosine of 210, the cosine of 210 degrees is the same thing as the cosine of 7 pi over 6. These angles are identical to each other. And so we know that the cosine comes from the x-coordinate, so we know that the answer is going to be square root of 3 over 2 in absolute value terms. What we don't know is this a positive or a negative number? That's what we don't know. So we go back down here to my little grid here, and I know that if I'm dealing with pi over 6's, if I start there, I'm dealing with no pi over 6's. Over here, I'm dealing with 6 pi over 6's. All right, all the way back around, I'm dealing with 12 pi over 6's. And if I start back at the beginning again and go halfway between 0 and 6, I'm at 3 pi over 6's right there. And then if I go 3/4 of the way around, I'm at 9 pi over 6's. Well, I want to go 7. So if I start here and go to here, I've gone 6. I can't go all the way down to the fourth quadrant because that's too far. So I must be in the third quadrant, which means my y's are negative and so are my x's. Therefore, the final answer is negative square root of 3 over 2. The cosine of 210 degrees is negative square root of 3 over 2. Of course, if you know your unit circle by heart, you can pretty much go straight to that. But the answer circled up there is negative square root of 3 over 2. Now, I'm not sure that you're going to get this on the test. I guess I probably will use this in some cases. This gives you a hint. It says use the partial unit circle below to help you evaluate the function cotangent of 4 pi over 3. So we want to find the cotangent of 4 pi over 3. So we need to know where 4 pi over 3 is. Well, remember, pi over 3 is the same thing. Remember, if this is the hand trick, this is the thumb, this is the pinky, and then you have your forefinger, middle finger, ring finger. So this is the forefinger. So we know that pi over 3's come from there. So we want to find the cotangent. Well, remember, the cotangent of an angle is the x-coordinate divided by the y-coordinate. So in this case, our cotangent in absolute value terms is the square root of 3 over 2 divided by 1/2. And if you will remember, in class we talked about this. When we take one fraction and divide it by the other, the end result, if the denominators are the same, that's what this is based on, the end result is the 2's go away, and we're left with one numerator over the other. So the cotangent of 4 pi over 3 in absolute value terms is just simply going to be the square root of 3. Now again, what we want to know is this an angle whose x value is positive or is it negative? Well, this is where we go back. I'm going to erase the hand part. I hope you got that. If you didn't, pause this video and get it. So, I know that if I'm dealing with pi over 3 units, I know that if I start here, I've gone no pi over 3's. I know if I've gone here, I've gone 3 pi over 3's. All the way back around to 6 pi over 3's. So if I go halfway between 0 and 3, that's 1.5, and down here is 4.5. All right, I need to go 4 pi over 3's. So here to here is 3 of them. If I go all the way around to here, I've gone too far. That's 4.5. I just need to go 4. So here again, my angle is in quadrant 3, which means both my x's and y's are negative. If both the x's and y's are negative, when I divide the 2 out, I get a positive square root of 3. Because remember, I am dividing a negative x by a negative y, a negative x coordinate by a negative y coordinate. So therefore, I get a positive square root of 3. Okay, this is a word problem that deals with right triangle trig. The cable supporting a ski lift rises 5 feet for every 8 feet of horizontal length. The top of the cable is fastened at 875 feet above the cable's lowest point. Find the lengths B and C and find this little, looks like a little misprint here. This should be theta right here. find theta, or in other words, to measure the angle. So what we want to do is find the missing parts of this picture here. We want to find B, we want to find C, we want to find theta. Well, we have a right triangle, therefore we can use right triangle trigonometry, which means we can use the SOHCAHTOA. The question is now that we know we can use it, how do we use it? What do we do about this? How do we handle this type of problem? Well, what we're going to do right here is we're just simply going to look at the fact, all right, if we wanted to use the sine, we need to know the angle and the opposite or the hypotenuse. Well, here's our angle. We don't know it. We only know an opposite. That's 875. We only know that. And we don't know a hypotenuse. So we can't go and find this angle yet. So the next thing we want to know, what about B? Well, we need to know at least two sides if we want to use the Pythagorean theorem. Same thing with C. So we're kind of stuck here. But we have a little clue here. It says that the cable rises 5 feet for every 8 feet of horizontal. So I have a little pre-drawn picture here. If you want to look at it, we can draw little miniature right triangles. In other words, we know that for every 8 feet we go horizontally, we go up 5 feet. For every 8 feet we go horizontally, we go up 5 feet. So here's what we have right here. There's a couple of ways to do this. Number one, we know that we need to rise a total of 875 feet. All right? The rises are broken up. I'm going to use my green marker here. The rises are broken up into 5-foot increments. Okay? So one way to look at this is if I do 875 and I divide that by 5, I know I've risen 175 5-foot increments. 875 divided by 5 is 175. So I know just simply by doing this, I've gone 175, let's see, 5-foot increments when I rise. Sorry about the writing there. I'm rising 175 5-foot increments. Well, for every rise, I've also got a run or horizontal part right here. So if there are 175 5-foot rises, there are also 175 8-foot runs. Okay, so if I go to my calculator again, I do 175 times 8. So I know that I have a 1,400-foot distance from here to here. And I did that just by simply looking at, I know that for every rise of 5, I run 8. I have 875 feet total to rise, and 875 divided by 5 is 175. So there are 175 5-foot jumps up. Well, for every jump up, there's a jump over. So there's 175 jumps over. And if each jump is 8 foot, then there's 175 times 8, or 1,400 feet across. Right, now I'm going to minimize this part right here, so you make the stair steps, so you may want to copy this down. I'm just going to take this and group it, minimize the whole thing. Well, I've left half of it off, that's okay. I just want to get it out of the picture. I'm also going to erase this rise and run, this red and green writing here on the right, so if you want to copy it down, stop the video and do that too, because I'm about to erase it. So that's gone, just get the clutter out. So here's what we know then. We know that B is 1,400 feet. Now that we know B, we can easily find both theta and C. Let's go ahead and find theta. Well, here's something we know. We know that the tangent of theta is the opposite side length divided by the hypotenuse side length. Okay? Now, it does not tell you in this problem. It will tell you, or the answer choices will indicate that, but our answer for theta needs to be in degrees. It does need to be in degrees. This is not indicated in the problem. You would have to be told that, or at least in a multiple choice, you would see your answer choices are degrees. So I know that this problem is meant to be in degrees. So what I'm going to do is I'm going to go ahead and change the mode of my calculator to degrees. And the reason I'm doing that is I know already that for me to get theta here, what I'm going to have to do is take the arctan, 875 over 1400. And like I said in class, anytime you use the sine, cosine, or tangent button on your calculator, you need to make sure you're in the right mode. And the mode is determined by the angle that you're working with. And in this case, I told you it's going to be degrees because you're not given that in the problem. All right, that being the case, then, how do I do this tan raised to the -1 here? Well, what I do is I go to my calculator, and I'm going to clear this stuff out here. What I do to get that tan -1, I hit second tan, and then I type, so that's tan -1, then I just type in 875 divided by 1400. And that gives me 32 degrees, rounded. So I know then that theta is 32 degrees. Again, I know it's degrees because I said it was. I already know this problem. You would be told in the problem whether your angle is degrees or radians. So I know B is 1400. All right, I'll circle that. B is 1400 feet. Theta is 32 degrees. And then the only other thing I need to do is find C. I could do it with a number of methods, but I already know 2 of the side lengths. So I'm going to go ahead and use the Pythagorean theorem. So therefore, C is going to be the square root of the square of one of the sides plus the square of another side. And take the square root of that. Now, again, we could use this in pure radical form. Since we're talking about distances and stuff, we'll just go ahead and find the decimal. So I want to find the square root. All right, I'm taking the square root of 875 squared plus 1400 squared. And that answer is 1650.95. 1650.95. And of course that should make sense in that the hypotenuse should be the longest side. Now, are there other ways to do this? Well, yes. If we go back to our little diagram here in red, which I'm going to expand a little bit, we probably could have found theta just simply using this ratio of 8 to 5. In other words, theta could have been the tangent of theta is 5 over 8. And if I just simply did the arctan, right, if I did the arctan 5 divided by 8, I should have gotten 32 degrees also. Just showing you that there's more than one way to handle that. But that's basically how to do that problem right there. Okay, this one says the needle of the scale in the bulk food section of the supermarket is 30 centimeters long. Find the distance the tip of the needle travels when it rotates. Now, if you think about this, if you go to the produce section or even the butcher section sometimes of a grocery store, definitely the produce section, a lot of times you'll see a scale hanging there. And if you read the scale, what you have is you have a needle right here, and that needle will bob back and forth. All right, so we have a pivoting motion here, and anytime we have a pivoting motion, we're going to use theta is equal to S over R. Anytime we have a pivoting motion, we're going to have theta is equal to S over R. Well, if we draw this out, we know it rotates through 72 degrees. In other words, the angle that it makes is it, think of windshield wipers. It swashes back and forth. It goes through 72 degrees. And we know that the needle itself is 30 centimeters long. So if we go and we put some stuff in here, oh, and it says find the distance, the tip of the needle. Here's the tip of the needle. I'm putting it as a big dot. We want to know the distance that this thing travels back and forth. So what we want to find is S. So we have theta, 72 degrees, is equal to S over R, which is 30. So S is going to be 30 times 72 degrees. Now, if we just stop right there, we're not going to get the right answer because, remember, when we did this, this theta is equal to S over R, your angle has to be in radians. So we got to convert 72 degrees to radians. So we just simply do pi over 180. And by doing that, that's going to convert for us. So now all I need to do is go to my calculator, and I am going to, right quick, I'm going to group this off. what I'm going to do is I'm going to slide it over to this side because I know my calculator's going to cover it up if I don't. Okay, now that I have that, I'm just going to simply type in 30 times 72 times parentheses pi divided by 180. So it's 30 times 72 times pi divided by 180. And so I know that my needle tip travels a distance of 37.7. I think that's what we're around to. Just says the distance. All right, and since we're in centimeters, we know then that this travels 37.7 centimeters, or 38 centimeters. Okay, the next problem. This says to use a calculator to approximate two values of theta, and you have a little condition, theta 0, 2 pi, that satisfies the expression the cosecant of theta is 1.771. Now, this is a tricky problem because you have a condition. What you're supposed to do is find an angle that's between 0 and 2 pi radians. Now, if you look at your answers, all your answers are in decimals. Okay, so let's convert this 0 in decimal form to 0. 2 times pi is approximately 6.28. All right, so what you're wanting to do is you're wanting to find an angle that satisfies this expression. The cosecant of theta is 1.771. 1.771. All right, so you may have been able to tell I paused just for a second because I got distracted here. I had someone talking to me and I had to stop. But here's what this problem is looking for. These answers right here, and this problem like this would be multiple choice on the test. And these answers are angles theta in radians. So here's what this question is really saying. It's saying which one of these pairs will give you a cosecant value of 1.771. That's what this thing is saying. Which one of these pairs will give you a cosecant value of 1.771? So here's the way I do this one. I go to the calculator, and I need to be in radians because I need to be in radians because if I look up here, my condition was from 0 to 2 pi. That's a radian right there. Or in other words, my angles need to be between 0 and 6.28. So here's what I'm going to do. All right, I'm going to go to the y equals. I'm going to clear that out. And here's what I'm going to do. I know cosecant is 1 divided by the sine of an angle x. That much I know. So I'm going to go into my table, and I'm going to go to the ask function. And here's what I want to know. All right, let me delete all that stuff there. All right, well, that 41 won't go away, so let's just ignore 41 for a second there. All right, 1.385. 1.385 is my first answer in A, and what I want to know, does that give me 1.771? And it doesn't. It doesn't. All right, what about 2.542? That gives me 1.772. Now, I know that that's a little crazy. You know, my calculator is rounding a little bit more than some others. But that's 2.542 is a potential answer right there. The problem is both of those numbers don't work, so A cannot be an answer choice. All right, what else do we have? We have 0.6 as an answer choice. That also gives me 1.771, doesn't it? So therefore, I know if 2.542 and 0.6 work, then this has to be my answer. Now, I can keep on going, like I have 3.327. That's in this part right here. 3.327. That does not give me 1.771. All right, and so really I've used all the possible answer choices, or I've used all the angle choices up there, and the only two that work are 0.6 and also 2.542. So the answer must be B in this case. All right, this problem here says, given that the tangent of the angle is -8/5 and the sine of theta is greater than 0, find the cosine. Now, the way I taught you guys to do this was to do it in absolute value terms first. Draw a right triangle, and we know this. We know the tangent is -8/5. So in absolute value terms, one side is 8, the other side is 5. All right, I want to find the cosine. To find the cosine, I need my hypotenuse. Well, I'm going to find my hypotenuse by simply squaring 8 and squaring 5. If I square 8, that's 64. And if I square 5, that's 25. Now, the reason I'm doing this in numbers is because all my answers, none of my answers are in decimals. So if I do this, I get 89. And so I know then that my hypotenuse is the square root of 89. Now, that's just Pythagorean theorem there. If you don't catch that, come talk to me. We'll work through that. So I know that my cosine then, in absolute value terms, the cosine of theta is just simply going to be 5 over the square root of 89. And again, nowhere do we have 5 over the square root of 89, so let's rationalize it. So that turns out to be 5 square root of 89 over 89. Okay, so that means that I know my answer choices cannot be D, nor can it be A. I know that I'm confined to B and C right now. The big difference is my answer negative or is my answer positive? So this is where this sine greater than 0 thing looks like. All right, if my sine is positive, and my tangent is negative, I'm sorry, I shouldn't have done -1. If my sine is positive and my tangent's negative, knowing that tangent is the product of a y divided by an x, so if my x is a positive number and the quotient has to be negative, that means I'm sorry, I said that wrong. If my y is a positive number and my tangent or my result is a negative number, then that means the cosine must be negative. The cosine must be negative. And that's just simple division. Remember, the tangent is y divided by x. In this case, if I know my sine or my y is positive and the result has to be a negative number, and that means the divisor has to be negative also, which makes my cosine a negative number. Okay, theta is an acute angle. Use this information to answer the question. If the tangent of theta is 5/12, find the cotangent. All right, this should be really easy. We don't even need to do a triangle with this. If the tangent is 5/12, the cotangent is just simply the reciprocal. It's 12/5. And yes, you will have a couple of questions that are that easy on this. Then our last one, this was actually, my numbers got out of order. I don't know if you noticed this, but this is actually, I think, number 5 on the review sheet. I got out of order here. But this just simply wants to know which quadrant is the terminal side of the angle 9 pi over 5. Well, this goes back to that circle thing I was telling you about. We're dealing with pi over 5 units. In other words, we have 9 pi over 5 increments. So if I'm over here, I'm at 0 pi over 5s. All the way over here is 5 pi over 5s. Back around is 10 pi over 5s. And if we stop and think about it, halfway between 0 and 5 is 2.5 pi over 5s. And halfway between 5 and 10 is going to be 7.5 pi over 5s. I just simply need to go 9. So does it make sense that I'm going to be in the 4th quadrant? I've got to be between 7.5 and 10. So in which quadrant is the terminal side of the angle theta is equal to 9 pi over 5? It is the 4th quadrant.